Hi class, in this video we're gonna discuss about chapter 7, class 4. So in last lecture we learned about basic skills of how to price a bond and how to solve for yield to maturity and yield to call for a bond. But the most questions we had in the last lecture are for annual bonds with annual coupon payments. In this lecture we're gonna talk about semi-annual coupon bond with semi-annual coupon payments. Okay, and then we're going to discuss about the current yield and capital gains yield of a bond. And also 3 types of risk for a bond, including price risk, reinvestment rate risk, and default risk. The key formulas in this lecture is how to calculate current yield or capital gains yield for a bond. And when we add up these two yields, it equals yield to maturity, or the expected total return of a bond. Okay, let's first look at how we can price a bond with semi-annual coupon payments. Okay, we call a bond semi-annual coupon bond if the coupon paid by the bond is twice a year, okay, instead of once a year. There are 3 conversions we make when we calculate for semi-annual bonds. Okay, just like how we work for present value or future value question in time of value of money chapter, when we switch to semi-annual payments, we also make these 3 conversions. Okay, here we're applying the same skills to the bond situation. Change 1, we multiply number of years n by 2. Okay, so 2 here is m, compounding periods per year. Okay, here we have twice a year as our payment, so our compounding period should also be 2. And our total number of periods would be 2 multiplied by number of years. Okay, the second change we have to make here is to divide our nominal rate, RD, cost of debts, by 2. So we can have periodic rate input as I in the calculator. Okay, we use the nominal annual rate, RD, cost of debts, divide by 2, so we have the semi-annual rate or periodic rate. The third change we need to make is to divide annual coupon payments by 2, so we have semi-annual coupon payment input as payments. Okay, so N, I payment are the 3 things we need to make changes compared to how we work with annual bond. Okay, for N, instead of inputting number of years, we input number of years multiplied by 2 for a semi-annual bond. For I, instead of inputting nominal annual rates, we divide it by 2, so we have semi-annual rates input as I. For payments, instead of inputting annual payments, we divide that by 2, and we input semi-annual payment for a semi-annual bond. Okay, and for PV, it is still the bond price. For future value, it is still the call price or the par value. Example, what is the value of a 10-year, 10% semi-annual coupon bond if RD, the RD cost of debt is 13% and par value is 1,000? Okay, when the question is saying that this is a 10% semi-annual coupon bond, is this 10% annual rate or semi-annual rate? This is something people might get confused, but please remember, any wording like this means that 10% is the nominal rate, annual rate. Okay, 10% is the nominal annual rate or nominal annual coupon rate. Okay, this is telling us that this bond has a 10% nominal annual coupon rate, and it is a semi-annual bond. Okay, you have to separate these two questions, these two information here. Okay, and this RD, 13%, is the annual nominal yield to maturity or interest rate or rate of return for the bond. Okay, so for N, we're going to input the number of half years. So we use the 10-year in total multiplied by 2. We have 20 half years in total. For I, we need to input the semi-annual rate or semi-annual yield to maturity. So we use this 13, nominal annual cost of debt or nominal annual yield to maturity divided by 2. So we have 6.5 as our periodic rate or semi-annual rate. Okay, and for coupon payment, we need to use the par value 1,000 multiplied by the coupon rate 10%. Okay, however, the 10% is the nominal annual coupon rate. Okay, we need to divide by 2. So we know that the bond pays $50 twice a year. Okay. So we input N as 20, I as 6.5, payment as 50. For the future value, we input the par value 1,000. We compute for present value. The bond price should be negative 834.72. Okay, this is something we're paying, so it's a negative number. Here is an example of how to solve for yield to call for a semi-annual bond. If we have a 10-year 10% semi-annual bond with a par value of 1,000 selling for 1135.9, that can be called in 4 years for 1050. What is its yield to call? Okay, so we know the call price here is 1050. We also know that the question is asking for yield to call. Okay, the question is actually asking for nominal annual yield to call, not semi-annual yield to call. Okay, whenever the question gives you something or asks for a question, it is always giving or asking a nominal rate. Okay, here, the 10% semi-annual coupon bond means that this bond has a 10% annual coupon rate. And this bond is a semi-annual bond. Okay, so for N, we need to input 4 multiplied by 2, so it's 8 half years before the call date. Okay, remember we want to solve for yield to call, so we're inputting the call date instead of the maturity date. Payment, we need to input 1,000 par value multiplied by 10%. The nominal annual coupon rate divided by 2, so we know it's $50 twice a year. Okay, the semi-annual coupon payment is still the same, no matter when you call back the bond. And we input N as the dates to call, 8 half years. We input present value as our bond price we paid today, negative 1135.9. We input payment as 50. We input future value as call price, 1050. We compute for I. We have 3.568. Think about it. What is this I here? Is it a nominal annual rate or is it semi-annual rate? Exactly. This I here should be semi-annual rate. Okay, semi-annual yield to call. Because the N is number of half years. Because the payments is half year payments. So the I should be half year rate. It should be semi-annual yield to call. Okay, it should be the periodic rate. So if we want to answer the question, which asks for nominal yield to call, we need to multiply by 2. So we have 7.137% as the rate that a broker would quote as nominal yield to call. Okay. A further step is to calculate effective yield to call. It should be 1 plus periodic rate square minus 1, or 1 plus nominal yield to call divided by 2 square minus 1. So we have 7.26%. Okay, we're using the formula of how to convert nominal or periodic rate into effective annual rate. You can also work this out on the interest conversion worksheet on the financial calculator. Okay, let me repeat the process using the digital financial calculator here on my laptop. Okay, let me repeat the process. So here we're solving for semi-annual yield to call. We input 8 as N, 1135.9 negative as PV, 50 as payment, 1050 as future value, compute for I. Okay, we have 3.5684. Let me just quit or second quit. Okay, then I need to input this number 3.568 multiplied by 2. So I have 7.136 here. Okay, I think there's some rounding difference here. Okay. The next question asks for yield to maturity of this bond. Okay, this time N becomes number of half years until the maturity date. So it's 10 multiplied by 2. We can input 20 as N. For present value, the bond price is still the same. Okay, it's still negative 1135.9. We input as PV. Payment is still 50. Future value, we need to input par value instead of call price. Okay, and compute for I. So the only two change here I make is input 20 as N, okay, instead of 8. Input 1,000 par value instead of call price as future value. Compute for I. Okay, we have 4 as our semi-annual yield to maturity. Then we need to multiply by 2. So we have 8% as our yield to maturity or nominal annual yield to maturity as 8%. Okay, that's how we calculate yield to maturity, yield to call, and bond price for semi-annual bond. Next, let's introduce two groups of concepts for bonds. Okay, one is about bond return and the other is about bond risk. For bond return, we have the concept of current yield and capital gains yield. Current yield is a bond's annual return based on its annual coupon and current price, as opposed to its original price or face. Okay, so current yield is the annual coupon payment divided by current price. It stands for the return you're going to make because of the coupon payment you receive after paying for the bond price. Another return is capital gains yield. It is the rise or the fall in the price of a security represented by the percentage of current price. It equals change in price divided by beginning price. Okay, it is the price of the bond after year P1 minus P0 current price divided by P0. Okay, this is the rate of return you earn because of the price increase or decrease of the bond. Okay, so you are making return after purchasing the bond because you receive coupon payments. Okay, that's why you have current yield. Also because that the bond price may increase. Okay, so you would have capital gains yield. So that's why current yield is coupon divided by current price. Capital gains yield is the change in price divided by current price. If you add up these two yields, you have the expected total return of the bond or yield to maturity. Okay. Yield to maturity equals expected current yield plus expected capital gains yield. Okay, let's look at an example. Calculating current yield and capital gains yield. For a 10-year, 9% annual coupon bond that sells for $887 with a face value of 1,000. Okay, face value is the same as the par value, 1,000. Here we have the information that this is a 9% annual coupon bond. Okay, always remember this means that the 9% is the nominal annual coupon rate. So we use 9% multiplied by 1,000. We have 90 as our annual coupon. If we want current yield, we use this annual coupon payment, 90, divided by our current price, 887. The current yield is 10.15%. Okay, if we want capital gains yield, we have two methods to solve for capital gains yield. The first method is to use its definition. We can calculate the bond price after year P1 minus P0 divided by P0, so we can have capital gains yield. However, it's a little bit complicated to calculate P1. So instead of using the definition of capital gains yield, we had better calculate capital gains yield using the summation formula here for the yield to maturity. Okay, because we already solved for current yield, and we know that current yield plus capital gains yield is yield to maturity. We can just use use yield to maturity minus current yield, so we have capital gains yield. Okay, so the first step here is to get yield to maturity. The second step here is to get capital gains yield using yield to maturity minus current yield. Okay, so first step is to solve for yield to maturity for the bond, which we already learned. Okay, we can input N as 10 years, payment as 90, present value as negative 887, the bond price you are paying for, future value 1,000. Compute for I, you would have yield to maturity as 10.91%. Okay, step 2, you can just use this 10.91% yield to maturity you just solved for minus the current yield you just solved for, 10.15%. So we have 0.76% as our capital gains yield. Another group of concepts is risk about the bond. The first type of risk is called price risk or interest rate risk. It is the risk that a rising cost of debt or cost of raising capital from debt will cause the value or price of a bond to fall. Okay, if we look at the formula of how we solve for a bond price, we discount all the future cash flows, including coupon and par value, to present using the RD, cost of debt, or interest rate, okay, as the bond price. So whenever we have the same cash flow we're going to receive after purchase the bond, whenever the interest rate increases, okay, the denominator increases, the bond price will decrease. Okay, if the interest rate decreases, then the bond price increases. So bond price and this cost of debt here go in opposite ways. Okay, so a rising interest rate will cause the bond price to fall. That's the price risk or interest rate risk. Both long-term bonds and low coupon bonds get most coupons relatively later, and later coupons are more sensitive to interest rate changes. So long-term bonds and low coupon bonds have more price risk or interest rate risk. Okay, so for long-term bonds, because there are T in the discount rates, the T is larger. So whenever RD changes, 1 plus RD to the power of T changes more. Price changes more. So for long-term bonds, they have higher price risk or interest rate risk. Or for low coupon bonds, the money comes later. T is larger. So also, it has higher price risk or interest rate risk. Okay, example. Assuming we have 10% coupon rate and 1,000 par value for both bonds, but with different maturity, compared to your 10-year bond, compared to a 1-year bond, the 10-year bond should be more sensitive to interest rate changes, so it has more interest rate risk. Again, long-term bonds with higher T should have higher price risk or interest rate risk. Here we can see that when RD changes from 10% to 5% or change from 10% to 15%, the 1-year bond increase from 1,000 to 1048 or decrease to 956. However, the 10-year bond increase more to 1386 or decrease more to 749. When there's a same change in RD, 10-year bond has a bigger change in price. Okay, so we say 10-year bond has higher price risk or interest rate risk. Okay, we can see this graph that yield to maturity changes at the same degree, but 10-year bond changes more compared to 1-year degree. The line for the 10-year bond of the price change is steeper. Another example is 10-year bond with 1,000 par value, but with different coupon rate. Lower coupon bond is more sensitive to interest rate changes. Okay, so it has more price risk or interest rate risk. Again, here our RD can change from 10% to 5% or change to 15%. For 5% coupon bond, the price can increase from 693 to 1,000 or decrease to 498. Okay, we can use the change in the price 1,000 minus 693 divided by the original price 693 to calculate the percentage change. And for the 10% coupon bond, it could increase from 1,000 to 1386 or decrease to 749. And again, we can calculate the percentage change using the price after change 1386 minus the original price 1,000 divided by 1,000. And we can compare the change, and we can find that the lower coupon bond, 5% coupon bond, actually has a bigger change. Okay, so 5% coupon bond is actually more sensitive to interest rate change and has a higher price risk or interest rate risk. The second type of risk is reinvestment rate risk. It is the risk that RD will fall after bond matures. You will have to pay a higher price for another new bond when you reinvest. Okay, so long-term bonds and low coupon bonds have more price risk but less reinvestment risk. Okay, so imagine for long-term bond, it lasts longer, so you don't have to reinvest. You have less reinvestment risk. But for short-term bonds, they have higher reinvestment risk because, for example, if it's 10-year bond, when you take out your money after bond matures and try to reinvest in a similar bond, the interest rate may fall, so you may buy a bond with a lower rate of return. So that's the reinvestment risk. Okay, you may reinvest your money at a lower rate. Example, suppose you just want 500,000. You intend to invest the money and live off the interest. You may invest in either a 10-year bond or a series of 10 1-year bonds. Both of them have currently yield 10%. If you choose the 1-year bond strategy, after a year you receive 50,000 in income and have 500,000 to reinvest. But if a 1-year rates fall to 3%, your annual income would fall to 15,000. Okay, so for the short-term bond, 1-year bond, you have higher reinvestment risk because you have to take out your money after a year and reinvest in buying another 1-year bond. And the interest, if the interest rate falls, you are gonna buy a similar bond at a higher price with a lower rate of return. However, if you choose the 10-year bond strategy, you can be locked in a 10% interest rate and earn 50,000 annual income for 10 years, assuming the bond is not callable. Okay, so you have less reinvestment risk if it's a long-term bond or low coupon bond. because you are locked in the price. You don't have to worry about the decrease in interest rate in the market anymore. You could keep your rate at a high level for a long time. Summary. For long-term and low coupon bonds, they have higher interest rate risk, but they have lower reinvestment risk. On the other hand, short-term bond or high coupon bonds have lower interest rate risk and higher reinvestment risk. Question, which of the following is correct? Okay, option A is not correct because high coupon bonds should have higher reinvestment risk. Option B is not correct because long-term bonds should have higher price risk. Option C is not correct because low coupon bonds should have higher price risk. Option D is not correct because short-term bonds have higher reinvestment risk. Option E is correct. Long-term bonds have less reinvestment risk. Okay, so we can answer this question according to the graph here. Last risk of a bond is a default risk. In case if an issuer defaults, investors receive less than the promised return. Okay, so it's the risk that the issuer could go bankruptcy and you could not earn the return as expected. And we can evaluate default risk by using bond ratings. They are designed to reflect the probability of a bond issue going into default. Okay, we have the three biggest rating agency, Moody's, S&P, Fitch rating. Okay, so they have different ways of rating a bond, whether it's a prime bond or high grade or highly speculative or in default. Okay, A, B, C, D, they have different ways of ranking a bond, but we can always refer to the rating to when we consider a bond. Lower the rating, the higher the default risk. All right, we have one question, practice question here. If this company currently sell for $10.50 and have 6 years to maturity, annual coupon of 75, par value of 1,000, what is yield to current yield or capital gains yield of this bond? Okay, please pause the video. Try to work on this question on your own. For current yield, you could use its definition formula. If you don't remember, you can refer back to our notes. Okay, how we can calculate current yield. For capital gains yield, again, it's hard to calculate it by using its definition because it's hard to calculate the bond price after a year. However, you could calculate yield to maturity for the bond first and then minus current yield to get capital gains yield. Okay, please pause the video and try to work on this question on your own. After you finish, you could resume and let's look at the answer together. Okay, if you finished, you could resume the video and look at the answer with me together. Otherwise, you could keep pausing the video. Okay, so for the current yield, we could just use the definition. It equals to annual coupon bond or annual coupon payments, 75 divided by the current price, 10.50. So we have 7.14% as our current yield. For capital gains yield, we need to calculate yield to maturity first. Okay, so N should be 6 years to maturity. Payment should be 75 annual coupon payments. Present value should be negative 10.50. Future value should be 1,000. And we compute for yield to maturity, we have 6.4682%. Okay, we take the difference of the two. We need to use yield to maturity minus current yield. We actually have a negative number, negative 0.6718%. Okay, we have a negative capital gains yield here, meaning our bond price will decrease after a year. Okay, you are still making money by purchasing the bond because you have this current yield from the coupon you earn. So we have a positive yield to maturity and positive current yield. However, the bond price is decreasing and the capital gains yield is negative here. Okay, so that's all for Chapter 7, Class 4.